Yo, welcome to another part of this Castle of Cubes cut that we're doing for quite some days now. I guess it's 1 week now or something like that. So right now, what do we get over here? The same as last time, we get the timeout, execution timeout. And the thing is, I have it over here that like about the largest number that this code is tested up against is this number, which is I don't know, like this is a million. I think this is a billion. This is a trillion. This is a I don't know, man. Like a really big number, right? So I have made the code in my local environment says that at first let's note that this code fails because it says maximum recursion depth exceeded, and maximum recursion depth of this panel count, because panel count is calling itself until the thing is resolved. And so I added, just to see how deep we go, we are gonna print out rooms left by taking the amount that is passed into the function and subtract the rooms constructed. And what can we do is that I have tested this function with a smaller amount. This is 93,000, and it says rooms left, and it quickly passes down to 28679. Now that is very quickly, you see. So this code is actually pretty good, but if you test it out against this number, you'll see what's up. I mean, it's fast as we see it in the previous example, but actually it's not that fast, or in other words, this is very large number. Right over here, it takes up like 100 CPU, and it shall do that for about 4 minutes now, until it just says recursion depth reached, and that is so that stack overflow is prevented. So I got an idea of just making a little bit more simpler thing. First, let's make sure that this thing is copy and pasted. Paste. Now I have did it before and I'm gonna do it again, and that is to make an array of the cubes, because how it is, like, you first start with 6, then you do 5, then you do 5, then you do 4, and then you do so now we have 2 times 2 times 1 cube. So what do you do? Then you do 5 4 4 3. Now you do another one, like 5 4 4 3. Now you wanna do, so now you have 2 times 2 times 3. Now you do 1 2 times 3 cube, so you do 5 4 4 3 4 3, and now you got 2 times 3 times 3. To make 3 times 3 times 3, you do 3 times 3 times 1, and it looks like 5 4 4 3, and then again 4 3, and then 4 3 3. So after that you got 3 times 3 times 3 cube. So to go to 4 times 4 times 4, you do another 3 times 3 times 1 cube on top of that. So you get 5 4 4 3, and after that you go, of course, 4 3 and 4 3 3, and of course you need to like take my word on it, really. So now we got 4 times 3 times 3 times 1 cube that we have got to do. So it always starts with 5 4 4 3, and we have to do it 4 3 and 4 3 3 and 4 3 3. So that is 433, and now 4 times 4, it's 5443, with then 43433, and then that is followed by 4, and then 4. If we got, oh, I need to make a sketch on my book, because I'm thinking, like, I still may be wrong, but I still say, like, yo, I've been thinking about this for like the last week, so I got this 55443, and you got 43433. That's where we are at, and then we say 433. Oh yeah, 433, just like before, actually, and then 4333. Now that is up until the cube 4, and I'm trying to make some kind of sense or logic, so if I do 6, if I divide it by 5, just like so, to see some kind of reason, and to do a new line after each 5, or just say, like, select all of the 5s. Alright, those are all of the 5s, and just make them so, so I could probably make just like a simple, like really simple algorithm that outputs something like that, and then it's just exponential, and it could start yeah. So how to do that? I could ask my mathematician friend how to do it, and I guess that should be the best way to do it, but I should just try, I guess on my own first, right? Cause yeah. So it is challenging to start, like, it goes fairly easy from here up, and what do you say, like, this is, and where do we, like, this is first 5 and nothing's here, this is second 5, 1 is here, third 5, yeah, like how do we say it, if it says, so if we make a loop and then we say, like, the next version of 5, so we say for block in, I don't know, rooms, or just like for room in rooms, we say for every room. Oh, okay. Because, yeah, I mean, this is actually the number of rooms, right? 1 room, 2 rooms, 3 rooms. So for every room in rooms, you say 5, or like panels is 0 in the end, and you just say panels plus equals 5. Yeah, I mean, yeah, and that is silly. So say, like, if you increment it by 5, and then you could say that increment the next one by 5, or like next room panels could be in the beginning 6. Yeah, in the beginning there are 6. So you say if we start from the beginning and do it some kind of this way, we are maybe able to do it. So we can do like we can make do a test on that, and it doesn't work because of some kind of a funny thing. I don't even know what's up. Yeah, right here, because it just returns the wrong one. Yeah, all right. So we just remove all of that. You shut up, Discord. You can't disturb me right now. So we say 1 is 6. So we say, oh, we have to define it. Test, just to see. Panel count, we call it. Define panel count, and we got n as an input, and we say panels equals 0, and we say return panels, and that will of course pass the first test. And we could also do just return 0, but we could say next room panels is 6, and we say for room in n, basically. Oh, we need to make it like range n. Oops. In range m, we say panels plus equals next room panels, and that's that. Yeah, both tests pass, but this one fails, and so we say if we could say an if statement, or just like next room panels minus oh shit, where is minus? I never use minus equals. So if we do minus equals 1, yeah, 3 tests pass, you know, and now this one doesn't pass. So let's go a bit further, because this is quite a long jump. So right over here we can say at 3 there is supposed to be 16, right? There's supposed to be 16 of them, and if we test that, that's 15 should equal 16, you know. So that is because it is not this. Yeah, I mean, yeah. Now, what would be the best way to solve this problem? Because what it's doing is, instead of going 6 plus 5 plus 5 is 6 plus minus 1, 5 plus minus 1, 4. And next room panels is minus 1. And then we say, yeah, like how do we do it? We say, so right now we are just here. We could say if we enumerate it and check, we can enumerate it and check, because the 0th element is reduced by 0. I mean every 0th thing. the first element should not be reduced. The third element should be reduced. The fourth element should be upped. Alright, we can be quite... I am quite cowardly right now. I am quite cowardly. So, cause what it happens is with this like test-driven people that are teaching test-driven development, it's like simple. Oh, then I make it so, and then I realize that, and that makes my code better because I optimize it and shit. But what's happening here is I can just like write bunch of if statements, and then it doesn't serve. It is impossible to improve my code because it's so imperfect, I guess. Imperfect, like made with such a way. Yeah. So what do I do? Say, yeah, it starts with 6 panels, next room panels. Yeah, and should I really do it like so, you know, 4 room in range or some other way? Maybe this. Yeah, now I'm doing this way. So next room panels is -1, and right over here it fails. So will we have to enumerate this one is the question. Because I just say print n, and I've seen some like enumerate versus yeah, 0th one is printed actually. Yeah, so we say Python range versus enumerate. Right over here, this discussion. Range and enumerate. Fizzbuzz. If enumerate numbers. What are the numbers? Fuck no, man. Enumerate numbers. Yeah, enumerate numbers. Yeah. How to use range and enumerate. List, enumerate, start. Yeah, fuck you, just fancy shit. Well, I also thought that I shouldn't curse that much. I should use replacement words instead of like fuck you, fuck, or shit, you know? So if you got any ideas, write that comment. Heh. Anyway, nobody's even gonna watch this. So we haven't really learned anything. Maybe Python range function has an index length enumerate list. Yeah, because range function print range 10. Using the star operator. Yeah, like right now we should be... Shit, where is the... Oh my god, I lost it, I think. Not that one, not that one, yeah. Should we really use range n thingy? If we should do... That's indeed... Oh. Like... So this is star operator is used to unzip. So we say Python documentation and we do range Python class built-in types. List. Does that make a list? The arguments, so the range must be integers, either built-in. In for loops. Okay. The range type represents an immutable. Yes, so we say class range stop. When do we stop? Range examples. And then you make you can make a list out of it, but it's not a list by itself. An immutable sequence of numbers and is commonly used for looping a specific number of times in for loops. So what do we want to do is to do right now we do n times, and the first one 0 times, second test 1 time, third test 2 times, 3 tests fails when it loops over 3 times. And let's just return that. And what do we want to do is to say, oh shit, yeah, we actually came to see like the number of step, the value of a step parameter. The advantage over a list or type range object will always take the same small amount of memory. Yeah, we like that at this kata. Now, is there a way to get an testing range objects for equality? Oh, it's just I'm stupid. Room. Step. We could just call that steps because it's working in steps, and we say right over here, if step. Now what do we want to capture over here is to get these steps, or not actually. This is the 0th one, first one, second one has 1, third one. Like, is there a way to predict at which place the 5s shall be? Because the first 5, I guess I'm not doing that in TDD way, but fuck it, you know, the first 5 is at first, you know, if this is the 0, this is the first, the second 5 is at the second, you know, and the third one, third 5 is at the 0, 1, 2, 3, 4 is at the 4th place, and the 4th 5 is at the this is the 4th 5, so 0, 1, 2, 3, 4, 5, 6, 7, 8. It's at the 8th thingy. 8th. Now the 5th 5 is at the, so here is 8, 9, 10, 11, 12. It's 12. And the 6th 5 is at the 12, 13, 14, 15, 16, 17, 18 is an 18 spot, there are really only 18 elements up to here? Yeah, I guess they are. So if there is there kind of a reason? Of course there is. Like, it says one first, you could say right over here the rule is that whatever the like amount of 5, that's wait, what am I counting, and which place is the 5? So say in the first place is 5, on the second place is 5, so you could say 5 is at every place, but here you say the fourth place is 5. Okay, 5 is everywhere but not a third. Here is only 8, so you could say so 2. Is this a Fibonacci sequence? Like, no, it's not a Fibonacci. No, it's like, is this a Fibonacci number? 2, 3. Yeah. No, it's not a Fibonacci. Maybe we could do like a famous sequences and see if that relates to it. Wow, there are a lot of sequences. 1 times 1 plus 1 is 2. So 2 times 2 is 4. 4 times 4 is 8. And right here we got the same step, right? And the difference here is just the previous one. So here, will it also just be the previous one? If this is 18, oh no, this is the 8 plus 4, 4. Wow, this is so hard to think about. This is so hard to think about right now for me. So is there a way that alright, why it's confusing, and this is like the number between them, right? First 5 isn't the first, the second, fourth, 8. Oh, 18th. Actually, we're not interested in the positions. Yeah, because this is like the position in the list. We could just see the amount of characters between them. So first 5, second, or just like bring that back and just say the difference between 5s. The difference between is 0 over here. Here the difference is 1 element. Here the difference, the distance is 3 elements, and the distance is 3 elements again, and this one is 3, 4, 5. Here is 5 elements, and here is 1, 2, 3, 4, 5, 6, 7, 8. Here is 8 elements, and here is again 8 elements, and here is 8, 9, 10, 11. Here is 11 elements in between. Shit, that's some really mathematical shit right now. So you've got here 1, 3, 3, 5, 8, 8, 11. What it does is, how is it from 1 to 3? It's 2. 3 to 5 is 2. But 5 to 8 is 3. And 8 to 11 is also 3. And the next one shall be 4. I see a pattern. I just do not know how to describe it right now. I just hadn't found a way to describe it. And you can, like, if you are watching this video and see this like pyramid over here, you also see a pattern. It starts at the top, because if it would start at the bottom, it would be just cutting the, or maybe we do not need to look at it as this type of pyramid. We could just say that the pyramid actually starts over here. If we look for pyramid from here, and we say for like, yeah, and then what is the distance between the threes? Because threes are, I guess, +1 every time. Here is 3, here is 1 3, here is 2 3, here is 2 3, here is 3 3. So to teach that perfect practice or best practice, I mean, but I don't want to, because we could just say, okay, for over here you say you make a solution, and then you just say 4 3, and then 4 3 3, and then you just say 2 times the same 4 3 pattern, and then you just increment by 1 3 every 2 times. So if we ditch that and we say, and it actually starts already here. Oh no, it's 4 3 4 3, and then you say 4 3 4 3, 5 4 6 5 5 4. And that would be a recursion, so we could say, or not. Starter is so we say 6 5 5 4, and that's it. Oh no, 6 5 5 4, and just 6 5 is a starter. And then we say new line is always then defined by 5 4. And then we say 4. What did we do? 4 step in range n, and we do if length of starter is not 0, then we say, panels is 0 in the beginning. If length starter is not 0, then we say panels increment it by taking the starter thingy dot pop the 0th one, and then we return the panels. Oh, still the first 3 tests pass. That could be a refactor. And then we say and then we say for, and then we wanna start at this one, so we say else panels could be plus equals just new line dot we could be just popping off of it, but then we shall get an index error with this one because it will say nothing over here left. Yeah, so right now there are like 2 frontiers. One is to figure out this mathematically, one is to figure out a proper way to do this, and I guess if I knew this mathematically, I could also do that here, but I don't, and I try to cheat over here, but to cheat over here I need to be like familiar with the generator functions, I guess. I think that would be way more helpful than this. Or yeah, conceptually and stuff like that. So now, is there a different way to do this? Say 5, 4, and like, is there a way to yeah, that was the question, like to know the difference between steps, because this is like 0, 1, 2, 3, 5, and how do you check if you're at the beginning of the new line? Alright, scratch that. Say panels, you say 0 in the beginning, and starter is gonna be, or just it feels good to just delete everything, but yeah. So starter is gonna be actually the up all the way up to here. So just say copy that, paste it here. Over here. So yeah, that whole thing is a starter, and it doesn't end. It should end right here. Am I gonna get like a is the battery? Yeah, the battery is charged. So the starter, and we get an index error again. Oh, we're not gonna get an index error because there's not an else function over here. And then we shall just say new line is 543, and then we shall say oh, I think we should end it right over here. 5443, and that should end it right over there. And you should say if chars left equals to 0, then you should say then you want to start picking up from the new line, so you say panels plus equals, yeah, iterate through the new line, and what we're popping again, so you say new line dot pop. We try that, and we catch an exception, except, and what do we do then? We say this is characters left is 0 in the beginning, but it should be like incremented by some type of function. So here it's a note to self, increment by the number of 4s and 3s left in this line, and then we want to redefine the new line property to 5443, and that's it. So elif chars left equals to 0, we actually want to move that over here. And if charge left is more than 0, then we like another algorithm for 4s and 5s. And then else something went wrong, we don't know what. Run for your lives. Expected an indented block. Okay, yeah. If charge left is more than 0, yeah, then we can look like at the number of lines. Number of lines is started right, charge left is 0, and that is at the beginning. So right here you can say elif instead of else is 0. Increment by new, and also increment the number of 4s, and this I guess pours into increment the number of lines, because number of lines in the beginning, I guess we start right here, so we say what, 1 2 3 4 5, I guess, or we started like 0, so here is 0, then you say 1 2 3 4 5, we pass that. Say how does it go? Yeah, it failed. 1 3 2 should equal 1 4 1. Yeah, alright, so this is already getting kind of out of hand in my head. So if characters left is more than 0, we want to make a function for the next, and we can use list as a helper and then learn about generators if we need it. And we say next line elements, and what we can do is we can define next line elements over here, and over here we just say we say panels is plus equals, and you want to say next line elements, and you say pop from it. And what do you want to pop from it is that you want to pop the, I guess, the first element. You don't even need to get the index or anything, and you do not even need to like have this variable then characters left, because you have the next line elements thing going on. So if elif next line elements is not 0, length, if that is more than 0, just pop if length next line elements equals 0, do something. Alright, increment by number in this line. So if next line elements is 0, try So if next line element is 0, then we do then we wanna pop from the new line, then we want to create a new line, and if that runs into an error, we make a new line and a new, and redefine next line elements to something. So that is the only thing that we have to do. Yeah, comments live, fuck comments. Next line elements, how should we tackle them? Because we say 4 3 4 3 3 4 4. So we could say we start counting over here. So this is the number of number of lines is we say number of lines is plus equals 1, and then you say new line is that. In next line elements, if we start at the 0th line and yeah, like right now I'm kind of confused. So we go to 1 2, we go, I think 1 2 5 4 5 4 3 5. All right, we get over here, and over here we say next line. So this is the first line, and so we say, oh, it feels like bee would sting me on my toe, but there's no bee, and I don't see even a spider. I don't know. Oh, it just got like sharp pain. Luckily it went away as quickly as it came. So we say 4 3. Oh, maybe it was glass that broke or something yesterday. I don't know. 4 3, and we say you do. So what happens? Next line elements. Oh, so you say 4 number 4. Now this is if this here is one step, how do you say abstract? This is 2-step abstract. So you say 4 line in range. So I'm just gonna use x's in range number of lines. We wanna say because this is pretty straightforward, like this is first line, second line, third line, fourth line. Maybe it should be good if we do a 5th line, but we say in that range, you say next line elements. And right now I'm thinking I could I'm thinking in the back of my head, and I think that I could optimize even this code to work through that with the use of generators and stuff like that. So that is certainly a thing to do. But next line elements, number of lines, next line elements we want to append, or rather extend, with the and we say with the extent we make the list, or like fours and threes, that is 4 3 4 time for y in x, so we need to put a range over there. That's two range functions. If you ask me, that's one too much, or two too much if there are two. 4 times 3 and 3. Oh, maybe we need to do it like this, a little bit simpler. So we say say 3 4 4 and 3, and we say extend 4 and 3, and then we also extend, and then we say 3, and then we say we make 3, we do like 3 times what? Times x, and say next line elements dot extend x. No, 3. 1 3 1 should equal 1 4 1. Like if the 6, is this gonna be more larger number? 1 3 6. There's like shit. If you do this like 20, I hope that's gonna be larger one, because yeah, it should be. So is 3 times x, so 3 times, so it's 3, so it's the times that's looping if the so here is one, no, here is 1 2 3 4, so it's 2, it's 1, like 1 is here, and then 2 is 2 more, that's 18 of them, and then 3 is even more. So yeah, I like, this is kind of too much abstraction for me right now. I'm gonna go to the store, I think, and come back.